Okay, let's say we want to look at a Newman projection for this compound. And really, we can do a Newman projection around any single bond. But for this example, let's do it around this single bond right here. Okay, so that would be basically around carbons 1 and 2. Okay, so one of the first things you want to do, which is going to help you out, is show some three-dimensionality with this molecule. So let's draw this so that we have dashes and wedges to show the tetrahedral nature of these carbons. Okay, and at this point, we're just going to do it somewhat arbitrarily. Eventually, when we get into stereochemistry, we'll see that we can't always do that. Okay, but here, maybe I'll make on this carbon, this ethyl group as a wedge, and I'll put the hydrogen in, pointing back, and then at this carbon, I'll make one chlorine pointing out, and I'll go ahead and do my hydrogen in the plane, and I'll make the other chlorine pointing back. Okay, so again, this is the bond we're interested in. Okay, and we'll look at it from this direction. So if this is an I, we're going to look along this bond. This is going to be our front carbon. And then this is going to be our back carbon. Okay, so we want to translate this into a Newman projection. So I'll go ahead and draw a big circle to represent my back carbon, a small circle to represent my front carbon. Okay, so now if I'm looking in this direction, I have one chlorine pointing to my right, one chlorine pointing to my left, and one hydrogen up. Okay, so we can go ahead and draw those in. There's our hydrogen pointing up, our chlorine to the left, and our chlorine to the right. On this back carbon, then, looking in this direction, I have this ethyl group pointing down. Then I have an ethyl group pointing to the right and a hydrogen pointing to the left. Okay, and you should be able to look at your Newman projection and compare it to this three-dimensional structure, and you can see how this hydrogen and this ethyl that are in the plane with the bond, they're anti or on opposite sides, and then in the Newman projection, this hydrogen and this ethyl is also in an anti-fashion. Okay, so one of the other things we really want to be able to do is look at this and figure out at least relative energies, what some of our higher energy conformations might be and what some of our lower energy conformations would be. On our front carbon, our bulkiest groups we have are chlorines. And on our back carbon, the bulkiest groups we have are these ethyl groups. So it would make sense our least stable conformation would be the one that has these chlorines eclipsing with those ethyl groups. So we can draw that. I'll go ahead and leave the substituents on the back carbon in their same locations. And then I'm going to just rotate around this front carbon to line up and eclipse these chlorines with the ethyl groups. Okay, so we have this structure where we have these carbon or ethyl chlorine eclipses. Okay, it's not our only eclipse conformation for this molecule because we could rotate this so that a chlorine and hydrogen are eclipsing, a hydrogen and ethyl are eclipsing, and a chlorine and ethyl are eclipsing. But this one has our largest groups eclipsing, so this is going to be our highest energy conformation. Okay, then one of our more stable conformations is going to be one like this, where we have the groups staggered. Okay, and that's more stable or lower energy. Okay, so at the very least, given a pair of conformations, you want to be able to look at them and determine which is more stable, which is least stable. Okay, we could even draw another conformation. Let's draw one that will leave the back groups in the same position. Okay, but let's rotate this around so the chlorine and hydrogen are eclipsing. And we have this hydrogen and ethyl eclipsing, and a chlorine and ethyl eclipsing. Okay, so another high energy eclipsing conformation. If you want to think in terms of relative energies, I would say that these two chlorine ethyl eclipses are worse than a chlorine ethyl hydrogen ethyl eclipse. So this would be high energy but more stable than this. So out of these three conformations, we could rank this as 1, 2, and 3 in terms of relative energies.